All right, folks, so for today's video, we are going to be looking at how likely it is to roll a 7 when we roll two six-sided dice. So what we've got here is actually a sample space. And this is a little complicated, so I'm going to try to explain what's going on here. So what we have here are the value that's rolled on the first die and the value that's rolled on the second die. So these are combined into a 6x6 chart, which you see right here in the middle. I'm just going to circle that in blue so we can see what our sample space actually looks like. So for example, if you roll a 1 on the first die and a 1 on the second die, then you are up here in 1-1 territory. And I'm actually going to erase that so that we can highlight what we want to highlight. So today what we are looking for are ways you can get a 7 out of these 36 different possible rolls. So let's look right down here. Well, 1-1 is just a 2, so we're going to have to go a lot more further down. Here we go. Okay, so we got 6-1. That makes 7. If you look over, 6-2 is 8, so that's too high, but 5-2 is another 7. So you guys will actually notice that along this diagonal, we start to see the different ways to make 7. All right, and it turns out there are 6 of them. Okay, now we learned last time, at least a little bit, that probability equals successes, so the number of ways you can get a success, over the total ways that something can happen, right? So in this case, we have 1, 2, 3, 4, 5, 6 ways to get a 7. So the P of 7 is going to be 6 ways out of those 36. Now we can simplify this fraction. In fact, I'll show you what we can do. We can divide by 6, top and bottom. And that's going to give us a simplified probability of 1/6. Okay, so that is one way to look at this. And I'm also going to show you another trick on the next slide of how you can do this without going into the sample space. Okay, so a bit misleading because we are going to go into the sample space a little bit here. My error there. But I want to show you what we're going to do here. So in this case, instead of thinking about how many ways out of all the ways you can get a 7, we're going to conceptualize this a little differently. So I'm again going to highlight each of these ways to get a 7. And then we're actually going to apply the concept we learned the other day to how likely is each of those ways. Okay, so let's look at this. Oops, that's not what I meant to do. Let's look at this first one down here in the bottom left, the 6 and the 1. So P of not just 7, but actually 6-1. This is going to be the probability of getting a 6 on the first die, which is 1 out of the 6 numbers, and in which case we're going to multiply the probability of getting a 1 on the second die. So again, that's a 1 out of 6. So the probability of rolling a 6 and then a 1 on the 2 dice is actually 1/6 times 1/6, which if you multiply across the top and you multiply across the bottom, that gives you 1/36. Okay. Now, what you're going to see is that 5-2, the probability actually works exactly the same way. Okay, so we got P of rolling 5, then a 2. Well, there's still just one way out of 6 on a die to get a 5, and there's one way out of 6 on a die to get a 2. So again, that probability is going to be 1/36. I'm hoping you guys see the pattern. Each of these probabilities is actually going to be 1/36. Now, how many different ways were there to get a 7? Well, we said there's 1, 2, 3, 4, 5, 6. So what we see is that the probability of 7 can be found by adding together those 1/36s, of which there are 6. So what we can think about is multiplying 6 by 1/36, and that's going to give us that same 6/36 that we saw last time, which is going to simplify down to 1/6, just like it did last time. So this is a kind of similar way to think about this, but I think it builds on what we did last time, and maybe it will help some of you kind of conceptualize what we're doing here.